keys. We're not doing all three. So you guys can pick A, B, or C. Those that have one. C. So for number 1, part C, these are all x values. We're putting these in for x. So this would be 3 minus 5 times 0. And then we would figure out what each of that equals. So 3 minus 0. So f of 0 equals 3. Or f of x equals 3. Questions on that one? Okay. For number 2, we are looking for g of 3. So when x is 3, we're looking for what is that y value, which is 1. And then for number 4, that one was a little bit more challenging. So this one says we have this part and we have this given information. So if x is 1, then y is negative 5. So we're going to start with that by replacing h of x with negative 5. And then every time I see an x, I'm going to put 1. Because this would help us solve for k. So we'll do that first. So this would just be 1, this would just be k. So negative 5 equals negative 2 plus k plus 5. Or negative 5 equals 3 plus k. And if we solve this and get rid of 3, k equals negative 8. So now we have that part. Once we have that, now we can put that k value into the equation and figure out what h of negative 4 is. So for each of our x values, we put in negative 4. And start to simplify. So this would give me 16. This would be a positive 32. This would give me negative 32. And the negative 32 and 32 would cancel. So h of negative 4 equals 5. Questions on that? So we're going to do the last part of Unit 4 today. We did 4.1, 2, and 3 already quizzed and tested on that. And then the last part, we are going to do the notes today, do an activity and quiz next class, and then do the project, now the test, next week. So if you did not grab an iPad, go do that. So everyone should have notes that look like this. So first, before we get into what we're actually going to do, we're going to review a little bit. First, we talked about scatterplots at the beginning of the year. Notice our objectives are dealing a lot with using technology, determining the equation of best fit, regression. We'll talk about what those mean here in a moment. So first, let's review some vocab. Scatterplots are used to determine whether or not two variables are related. A trend is when a change in one variable affects the other. Trends can help us make sense of the world and help us make predictions. So we didn't use that word before, but we talked about different types of trends. So I'll let you figure out what this blank is. A blank trend occurs if one variable increases when the other variable increases. Positive. This trend is much like a line with a positive slope. And then a blank trend occurs if one variable decreases when the other variable increases. negative. This trend is much like a line with a negative slope. Then there was one other type. This is blank blank between the number of newspapers sold and the temperature in the following example. Anyone remember that other type? No correlation. There is no correlation. Okay, so previously we were using the word correlation instead of trend, but they are interchangeable, or association. All of those are interchangeable. On the next page, those words are listed again so that you remember what they are. Another term to describe two sets of data that have a connection or a relationship is a correlation. That's the same word for both lengths. Correlation between two sets of data can be positive, negative. It can also be strong or weak. We talked about that at the beginning of the year, depending on the line, depending on the shape. It could also be linear and nonlinear, but we'll get into that later. And then we can strong. So on the next page is a lot of just review on scatterplots in general. That is there for your practice. We're going to go to the back of the next page and look at some of these examples. So these are given certain scenarios, and we're going to just determine if they are positive, negative, or have no correlation. So the number of hours a person has driven and the number of miles driven, they're positive. These both increase together or decrease together. If I don't drive, then I don't have any miles driven. But if I drive a certain number of hours, then the number of miles is going to go up. The number of siblings a student has and the grade they have in math class. No correlation. They're not related. The age of a car and the value of a car. Negative. Because as the older a car gets, as its age goes up, its value goes down. If it's an antique, sure, but usually not. Not all cars are antiques. Okay, we'll do one more. The number of years a person went to school and their income. Positive. Usually the more years you spend in school, the higher you get paid. The more you get paid, there we go. Okay, and you can look through some of those others on your own time. Go on to the next page. We're going to do one more small thing of review before we get into what we're actually talking about. So in this table, this is going to kind of go back and review function notation. So if I had these x's and I wanted to find the y values, I would put in each x to find the y's. So that would be y equals 3 times negative 2 minus 4. And I would figure out what both of those are. And then what would that be? Negative 10. And then I'm going to do the same thing for the rest of the table. So if I put in negative 1, what would that give me? Negative 7. If I put in 0, what would that give me? Negative 4. What about 1? Negative 1. And then what about 2? So in each one, what pattern do we notice? Okay, so as not as it goes down, but as these go up, these are also going up by what?
3.
And that kind of goes with the slope. Because of the slope, that is going up each time by 3. So noticing patterns will help us with what we're about to get into. Okay. So when we talked about scatterplots, it was a lot of just plotting points, looking at the correlation, looking at trends, all those things. But now we're going to be finding equations that fit this data the best. That either the points surround it the best, it goes through a certain amount of points the best, whatever. And we're going to talk about how to do that. So first, I want you to reset your calculator. Second plus 712. Please. Reset your calculator. And then if at any point you get lost, all of the steps are in your notes. So we reset the calculator first, second plus 712, and then we're going to put this stuff into stat. But before we do that, let's talk about in stat, and I'll show you how to get there. The L1 is usually your X's, the L2 is usually your Y's. So in this, if I have time and hours and grade, would the time depend on the grade or would the grade depend on the time? Yes, the grade would depend on the time. So that's your Y, that's your X. So in your calculator, you're going to go into stat, which is right next to the arrows. And then you should be on edit. Go ahead and hit 1 or enter. And you're going to put those numbers into that table. So you can either type it in and hit enter, or you can type it in and hit the arrow down. And then when you want to go to the next one, hit the arrow over. Go ahead and fill out that table in your calculator. To reset it. Second plus 712. And then we're going to Kevin, did you put this in your calculator? As you're finishing that up, I'm just going to show you how to, if you happen to clear a list, but we'll do that later. Now we're going to move on to step 2. So we're going to go back into stat, and we're going to scroll to the right, go to the right for calculate. And then which of these things do we think we're looking at or looking for? Which of these things do we think we're going to go find or go looking for? I'm hearing whispers, but not actually hearing what you're saying. What's something that stands out for something we've been doing a lot of? Have we been dealing with quadratics, rubrics, or cubics, quartics? What have we been doing a lot with? So linear regression, but there are two of them. We're going to ignore 8. We want the one that looks more like our slope-intercept one. You're going to go into 4 by either going down to 4, hit enter, or just hitting 4. Okay. Is anyone not at this? What part are you in? So at step 2. Go back to the stack. Anyone else not there? Then, still on step 2, we're going to go down to store regression equation. That's what that stands for. And we're going to hit alpha, trace. Alpha green, trace is at the top. You'll get some menu that looks like this. You can choose whichever one you want, but we're just going to go with the first one, so hit enter. And then you're going to hit enter 2 more times. If you did not get this, raise your hand. Jaden, did you get it? So step 2, hit alpha, trace, alpha, trace. So this, on the next page, is going to be your line of best fits. We're going to write 3 decimal places. So 6.012 x plus 53.61, we're going to round to 6. Not your computer, your iPad. You're not using computers today. I need you to grab your iPad. Thank you. Yes. The next page. Should be at the top. So then it's asking us to predict different things. So predict the grade given for a student who studied for 0 hours. So we are given hours. Is that X or is that Y? So if we're given X, we're looking for Y. So you can do one of two things. Either do this algebraically. So use our equation, put 0 in for X. That would look like this. And find your Y that way. Or I'm going to show you how to do this in the calculator. So this part only works if you did that store regression piece. If you didn't do that part, this will not work. So we're going to go into the table, second graph. You should have these values, and this will help us answer these questions. So when X is 0, Y is 53.616. I'll just round that to, you can leave it as 616 or do 6.62, either or. So then for 6 hours, what would that answer be? I heard it, but I didn't actually. 89.61. And again, that's rounded. But if you put all three, that's fine. It's like in general, however many decimals you use in your equation, use that many in your answers unless it says otherwise. Okay. For the last one, it says how many hours do you need to study to get 100% greater than 100%. So now we're given a grade, which is what value? Y. So now we have to find X. So that would look like this. Where we solve this for X, so let's do that, and then I'll show you where you can find that in the calculator. So if we subtract that, what would that give us? What was your question? Just hit second button. So everyone should be subtracting that on the calculator, figuring out what that is. What is that number?
46.3.
46 point, say that again. 384, thank you. And then divide both sides by 6.012. What is that X value? One more time. 7.671. Okay, so that's like a very specified answer. It's pretty accurate because we have multiple decimals. The lower amount of decimals you have, the least accurate it becomes. So get more decimals because then your answer will be more accurate. In your calculator, if I go back into the table, again, this only worked if you did that stored regression. And I'm looking for when my y value is more than 100. Well, at 8, if I just wanted a whole number, I could definitely say at 8 it's more than 100. But if I wanted to find that specific 7.715, I'm going to change how this looks. So we're going to go into second window. So windows at the top. We're going to change this to start at 7. And instead of it counting by ones, I want it to count by 0.5. Second window. After you change those values, go back into your table, second graph. Now in my calculator, I see somewhere between 7.5 and 8 is where that's going to go over 100, which our answer was 7.7 something, so we're close. So I'm going to go back and I'm going to change it one more time. So second window. Now I want this to start at 7.5, and I'm going to change this to 0.1. And I'm going to go back to the table, second graph. Now I can see that between 7.7 and 7.8 is where that goes over. At 7.8 for certain, it goes over. If I wanted to keep going, I would just keep going back and changing that to 0.01, 0.001, and keep doing that until I get that exact same answer, which you could do that if you want. We're not going to do that. But that's how we would find that. We're going to fix this so that it's normalized if you are using the calculator for everything else. Go back to second window, change this back to some whole number, it doesn't matter, and then change this back to this one. Okay. Now we're going to do this in Desmos, and then you can pick and choose whether you want to keep using the calculator or keep doing this in Desmos. So go ahead and open up your iPads. And on that same page, it's a little blurry, but there is a table. We're going to be using that table. I'm going to actually zoom in so we can see this a little bit. Okay. So to add your table, you're going to go into the plus and make a table. You should see something that looks like that. Then you're going to start typing in your numbers. So I will start typing them on mine, and then if you can't read it off your notes, you can follow mine. just to have a chance. Now, I'm going to show you where this function is, and you can use this function, but you'll need to do what I'm going to show you afterwards, because this function won't be on the SLOB. So there should be this little thing in the corner after you make your table. If you click that, then this option at the bottom should pop up where you can click which regression you're looking for, and it'll give you that equation and those numbers. But we're going to find out how to actually make the equation. So if you didn't get that or didn't see that, it's okay. So one, you need to keep in mind your y equals mx plus b. Think of a line, the equation of a line. It's going to be similar. In your table, we have x1, y1. So we're going to be using that. So I want you to type this. y1. And then in the ABC, look for this little squiggly line, it's called a tilde. mx1 plus b. So you should get your equation to look like this. You're going to be given an m and a b. That is what you're going to use for your line of best fit. Anyone not get that? So the order of how it looks doesn't matter, as long as you've got that same m and same b. Okay, so you would type in that equation, y equals 13.07 x plus 168.212. Whoops, except that's not where I'm supposed to put that. So put in your equation afterwards, and then back at your table, there was a little magnifying glass at the bottom. You click that, and you'll be able to see your line of best fit and your data. And you'll see that this line goes through most of these points. It's surrounded by most of these points. The R squared tells us how strong or how weak this correlation is. The closer it is to 1 is the stronger it is. So I can say this is pretty strong. Okay. If you had to find some value, so in this example we don't, but if we did, let's say I needed to find when x was 50. Just giving some example. I would type in x equals 50. I would look for where do those two lines cross. That's not what I meant to do. There we go. And that y value would be my answer. Yes. Did you click the magnifying glass? with the table at the bottom of the table. Oh, yeah. I could do the same thing with y as well. So let's say I wanted to find my x value when y was 100. Then I would look at where those two lines cross, and that x value would be my answer. Okay. Who prefers using desmos? Okay. Who would prefer still using the calculator? Okay. So you have that choice. For the next problem on the next page, I want you to try that using either or. After we do this. Alright, so in number 3, before we start this, so before you start to put this in your table, we have to change something on it first. So anytime you see years, like actual years, you're going to change that first one to 0. And every year after that is going to be how many years has it been since the initial. So this is your initial year. So from 1920 to 1925, how many years has that been? 5. And then every year after that, still going back to the initial. So 1920 to 1930, 10. Now in this case, I can see that these are each counting by 5, so I can just count by 5. But in general, don't assume that. Always double check and count how many years has it been from each, because it could not follow that pattern. 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. So we're not going to put those years in. We're going to put 0 through 80 in instead. Be very careful because there are a lot of decimals. So go ahead and make your table in your calculator or in Desmos and put all of those values in. In Desmos, something that is nice about that, when I start to put a pattern in, so let's say I put 5, it'll start to recognize that pattern, and then I can just keep hitting enter. I can do it better on my computer. I can keep hitting enter until I get to the number I want. So everyone should be putting in the table for number 3. Make sure you ended up at the same line. If you didn't, you may have missed the number. equation, you need to go through all of your tables to make sure your decimals are correct, your numbers are correct. Make sure that your numbers in your equation match the numbers at the top, all of those things. One decimal place off could throw your whole equation off, so you got to be really careful with these. So that would be your equation for line of best fit for that answer at the bottom. And then for life expectancy in 2010, how many years has it been from 1920 to 2010?